Hello guys, welcome to AR Tutorials. Today is day 5 of solving Leet Code DSA questions daily, and today we are going to solve Leet Code question number 53, that is maximum subarray. Although this question has been labeled as medium on the Leet Code, but using a specific algorithm you will find this question very easy to be solved, just like it's an icing on a cake, because using that specific algorithm you will find how easily we could find the sum of the subarrays or the count of an subarrays. Various types of problems can be solved using that specific algorithm, and the name of that algorithm is KADANES algorithm. KADANES algorithm is basically a DSA oriented algorithm which has a specific domain. In that domain, if there are contiguous subarrays or vectors, if you have to found the continuous count or continuous array sum, then you can use KADANES algorithm very oftenly. Now this question, what it demands, let's see. Now here we have given a vector, the vector of n number of elements. We have to find the highest sum of continuous array indexes. The array indexes should not break in between. We have to find such index which is a high, we have to find such sum instead which is highest among all the addition of this, all the additions of subarrays in the vectors. Now answer is 6. Why? Because 4 minus 1 plus 2 plus 1 gives the sum of 6, and it's highest amongst all the uh, other contiguous arrays in the vector. This question can be solved using brute force, using normal without any algorithm also. There you have to run two loops ij and you have to find all such pairs, and that would be the complexity of n square and space complexity of n, but because you have to store the values, so it could be very time consuming code. Instead, if you use KADANES algorithm, nothing will be there, only in one pass you will get the answer without using any extra space. So let's visualize what is KADANES algorithm. Now KADANES algorithm, you have a series of you have series of numbers in a vector. Now what we will do, we will first see what KADANES algorithm basically stands upon. The KADANES algorithm, basically there are two variables. First is pre-sum, which basically consists of the sum of the array elements, and second one is a maximum. Here we have to give it as the int min, because we have to give it the minimum value possible in the integer, so that we can replace it with the maximum number, as we have minus numbers here in our array, so that we can also replace it with the minimum integer. So first of all, what is the condition? Whatever, if our pre-sum is less than 0, if our pre-sum is less than 0, then we consider pre-sum is equal to 0 only. Here I will write, if pre-sum is less than 0, then we have to assume it as 0 only. This is the first rule, and after that we have to if we have got the positive values, then we have to add it in it, and whatever maximum value we'll get, we'll replace with the max. Now once I start implementing, or once I start dry running, you will get the idea more clearly. So let's start with it. Now first element is minus 2. Now what I'll do here, I'll first what I'll do now, my first element is 2. Now I'll add it. Now it is minus 2, so it will go with minus 2. So first, what is our prefix here? 0 prefix is a default one. Now we'll go here. Now let's take the prefix as it is, and minus 2 will give us minus 2 only, which is less than 0, which is less than 0, so it will be 0 only. So the next is our minus 3. So again, what was our final result? That was 0. Then I will take minus 3, it will become minus 3 again, now which is less than 0, so we have to again go with the 0. Now for a fact we have came up with the positive number, so it will get added. So what it will be? 4, which is uh, greater than 0, so we have to take it as 4 only. Simple. Now next is -1. So 4. Now I'll go with -1, because after 1 there was a -1, and -1 we have to take as it is, because we have a positive number already existing in our pre-sum. Now one step I have forgotten you to tell you, that in our previous we have got the sum as 4. Now 4 we have to replace in the max place, because 4 is obviously greater than minimum integer. So first it becomes 0, because when we have done our pre-sum -2, it became 0. So obviously 0 is greater than a minimum integer, then it became 0, and then it became 4, because as we have got 4 there, and now once it has become 3. Now as we know that the 3 is less than maximum, so we'll not replace here in maximum. 3 we'll let it be as it is. Now our pre-sum is 3. What we'll do now, 3 is there. Now we have to take -2, so here we have taken -2, it has become 1. No problem with 1, it is less than maximum, it is less than max, so we will not touch max. Then we have 5, so 1 plus 5, we have got 6, and obviously 6 is greater than the 4, which was already there in maximum, so we'll replace maximum value at 6. So here it has become 6. Now in further part, what we will do, we have left with some few elements. Now we'll solve. Now we have got 6. Now there was -3 element, so -3 element, which is leads to 3, and which is less than the maximum. Now we have left with what? We have left with the maximum element as 6. We have to ignore these elements as we cut and go forward, so we have remained with the 6, and we have to return it. So this is our answer, 6, and yes, we have solved this, and we have also got it. We have seen it in our example also. This pre-sum is very easy to find. We have only used the one formula, pre-sum plus equals to the what is your num of array of I. It will just calculate whatever is there in your array, and you will get the pre-sum values. So we'll see the code now. The code is also very easy. The first we have to take maximum element, because we have to find what is maximum there. So int mean, as I have assigned it first, then sum at 0. Sum I was telling you pre-sum, but it is also okay as sum, and I have calculated the size n. Now we iterate through the loop. The loop starts from 0 to n. What I have done, as I have told you before, I have calculated here the pre-sum. So this is the sum, which is plus equals to number of i's. Now what condition I have told you, that if the sum is less than 0, you can put directly put sum is equal to 0. So I have put it here. If my sum is less than 0, I'll directly put my sum is equal to 0. Then what was the second? If my sum is greater than the maximum, then what I'll put here, maximum is equal to sum. That sum value will be replaced with the sum. Now this 3 lines code is called as a KADANES algorithm. It is very easy to implement, and very very easy. Not at all hectic and tedious work is there. Only logic matters. Here the KADANES algorithm works very fine. Now we'll submit it, and it will be the most optimal solution. If you are in a interview, if you show this algorithm with the name of KADANES algorithm, the interviewer would be very impressed. So that's it for today. Thank you for watching this video. I hope you have learned a lot. I still wanted everyone to share this video with your friends. If they are trying the DSA questions daily with me, they can also learn. So please subscribe to my channel, and please do comment if any improvement is required from my side. It would be a great help for me, that if you required your feedback, it would be very valuable for me, that I am in a learning phase. See, your feedback matters to me. So if you can give your feedback, please give me, and please share this video with your friends. Thank you for being tuned.